Alright, we are in section 4.3, and in the previous video we looked at some really important logarithm rules, and now we're going to actually apply them to simplify some stuff. So you'll notice that I'll be able to do these from memory because I've memorized the log rules, and that's why you should memorize them too. Now, how do we know if something is simplified? In general, we want the argument of the log, in other words, the stuff inside of these parentheses of the log, we want these to be as simple as possible. So we don't want a times b times c, or we don't want y to the 30. We want to break it up so that it's as simple as possible. So let's look at the first example. Log base 10 of y to the 30. Which log rule would we apply on this one? We do this rule. If you have it to an exponent, you can bring the exponent down. So all you got to do is just take the 30, bring it down in front, and there you go. That would be the answer. And in fact, you don't technically even need to put this 10 right there, because if the 10 is missing, then it's automatically assumed to be log base 10. So, but either way, that's the answer right there. How about this one? Log base 4 of a times b times c. Well, if we look back to our log rules, we know that log of x times y is equal to log of x plus log of y. So that's the rule we're going to use here. So here would be the answer. Log of 4 of a plus log base 4 of b plus log base 4 of c. And that's it. So two things to notice here. First, because it was a times b times c, we can do the rule over and over and make it log of a, log of b, plus log of c with the pluses. Also notice that because it's log base 4, we need to write in the 4 for every single one of the logs. If you didn't put these 4s here, it would be wrong because it would be assumed to be log base 10. So you do need to put the 4s in there. All right, let's simplify the natural log of e to the 23. Like the previous example, we can bring the 23 down. So this is equal to 23 natural log of e, or e to the 1. So that's the answer, but we can actually simplify it a little bit more, because what is the natural log of e? What is that? Remember, natural log means base e, and so in other words, e to the what equals e? Well, the answer is 1. So this is 23 times 1, or just 23. So the natural log of e to the 23 is just 23. So it's good to know that the natural log of e is equal to 1. They kind of undo each other. All right, let's look at the next one. We've got log base 2 of x over y. Again, going back to our rules, if we have a fraction, we subtract the denominator. So this is just going to be log base 2 of x minus log base 2 of y. And that has to be a 2 there because it was a 2 in the original problem. All right, let's do the next one. We have log base 3 of 2x over y to the 3rd. So this is a really important example because it's going to be more than one step. So the first thing I would do is notice that the fraction is kind of the big structure inside the problem. And so I would start by using the fraction rule. Log base 3 of 2x minus log base 3 y to the 3rd. So that's the first thing we can do because of the fraction, is we can subtract the two logs. Now we can even go further, because notice that this is 2 times x, so you could write this as log base 3 of 2 plus log base 3 of x. Because remember, 2 times x, if it's multiplying, then it's a plus. So this all right here is just this part. Is there anything we can do to this? There is, in fact. Do you see how it's y to the 3? We can take that 3 and bring it down. So this is going to be minus 3 log base 3 of y. Notice we have a 2 inside of here, an x inside of here, and a y inside of there. There's nothing else we can do. That's the answer. So that was a two-step problem that used multiple rules. So let's take a look at this example. We have the natural log of ABC divided by DE. So again, the first thing I would do is I would attack the fraction. So this is the natural log of ABC minus the natural log of D times E. Okay, so you just take the entire numerator. Sorry, it's a little messy. You take the entire numerator and subtract the entire denominator. Natural log of ABC minus natural log of DE. Now we can break it up even further. So I'm going to come down a little bit. This would be the natural log of A plus the natural log of B plus the natural log of C. Now this is important. Do you see how we're subtracting this entire thing? We're subtracting all of ln dE. That means we need to subtract the natural log of D and the natural log of E. So in other words, we have to subtract all of ln of D plus ln of E. In other words, when you break this up with the multiply rule, this minus sign needs to distribute to both things. So it's minus ln of D minus ln of E. So here's how I would write the final answer. ln of A plus ln of B plus ln of C minus ln of D minus ln of E. Like that. So notice that A, B, and C are all positive because they're in the numerator, and D and E are both negative because they're in the denominator. Now this problem's a little bit ambiguous. I'm not sure if this E is the natural log E or not. So if it doesn't accept this in your homework, just change this natural log E to a 1 so that it's minus 1, because the natural log of E is 1. So that's why we tend to not use variables for the letter E, because it gets really confusing. Is it E or is it the natural log of E, or the number? Hard to say. All right, we have time. I think we can do these last three. We have the log of the square root of x. How can we deal with this? Well, we don't have any rules for square roots for logs, but we do have them for powers. So you want to rewrite this as x to a power. This is the same as log of x to the 1/2. And that's because 1/2 is what gives us the square root. And now that we have a power, we can bring that down in front. So this is 1/2 log x. Okay? So the first step was to rewrite the square root as a power, and then we can use the power rule by bringing the 1/2 down in front. So it's 1/2. So the log of the square root of x is the same as 1/2 times the log of x. So that's kind of cool. 2 to go. Log base 2 of the third root of x divided by y. First, let's do the fraction. So this is equal to log base 2 of the third root of x minus log base 2 of y. See how I did that? So log base 2 of the third root of x minus log base 2 of y, that got rid of the fraction. I think we can do, this is pretty much done now, but I think we can do some more to the third root of x. Remember that we can rewrite that as x to the third. So we can rewrite it like that. And now that we have it as x to the 1/3, because we took the third root of x, it's x to the third, we can now take that 1/3 and bring it out in front. So here's the final answer. One-third log base 2 of x minus log base 2 of y. Very good. I think we have time for one more. So let me kind of carve this one away. There's a lot of stuff going on here, so let's just get through it. I would write this as, I think I'm going to write it down here because it's going to be kind of long. So this is going to be, break up the fraction, log base 8 of m to the 5 6th root of x minus log base 8 of the square root of p 8th root of y. So we just broke it up using the subtraction rule. Now let's use the multiplication rule. This would be log base 8 m to the 5 plus log base 8 6th root of x minus log base 8 the square root of p minus log base 8 8th root of y. Now why is it a minus right here? Why is that a minus? Remember from the earlier example, if we're subtracting all of this, the minus sign would distribute to both parts of that. The way I remember it is, if it's in the numerator, it's going to be positive when it's broken up, and when it's in the denominator, it's going to have a negative when it's out there. So that's just something I use to help me remember to not forget that minus sign. I'm going to skip the next step. Let's just go straight to the answer. The 5 can come down. So there we go. Plus, now this is the 6th root of x. So remember, that's the same as being x to the 6th. So that's the step I'm going to kind of skip. So that 1/6 comes down. Oops. So that's 1/6 times the log base 8 of x minus, here we have the square root of p, so that's the same as p to the 1/2. So that's going to be 1/2 log base 8 of p. And then finally minus, here we have the 8th root of y, which is the same as y to the 1/8. So that's going to be 1/8 log 8 of y. Phew, that was a long one. That's about as hard as they get right there. We had to use the fraction rule, the product rule, and the power rule to make it like that. And you can see that the arguments inside our logs are all a lot simpler than when all of this was crammed in the log. All right, in the next video, we'll look at a few more examples, and then we'll be done with 4.3. See you there.